Okay, I should be recording now, and I'm going to go ahead and share the screen. So hopefully you see everything up here. So here's what we got left. Been working on this algebra homework assignment that's due this Thursday. It's a pretty long one. There's about 30 questions or maybe a few more than that. We'll take a look at that in a second. And I'm going to do some that we did in the previous recording. We got through about 16 problems the other day, and I'm going to do a couple of the tough ones, and then we'll move on. And then after that, all that's left is the practice test on algebra, the forum where you post the response to either one of my questions or a student's question. And then there's the test right here. And then the only thing after that, the last thing is that's due by May 2nd, but you can get it done early, is the praxis test. And that's worth some points, and there's no time limit on that. That's a really long thing. It's like 55 questions or so. The actual praxis test is like 58 questions, but in the actual praxis test is timed. You have about 80 minutes to take it. This is untimed, and you know, so at least it gives you good practice on it. So it's on everything that's on the praxis test, which we covered. So let's go ahead and go to the algebra bit and take a look at these. So here's the here it is. There's 30 problems total, and I'll go to teacher preview here so we can see it. And I'll review some of these earlier ones. Again, the first video from last week, the last video that I put up, shows the first 16 problems, you know, with a little bit different numbers or whatever, but they start off pretty easy because this is algebra, and we did actually, with some of the problems we did early in the semester with proportions and that, we had some algebra in those, so I kept those in there, but those were done a while back, setting proportions. And then this is on scientific notation right here, just reviewing some of these. So this third problem on scientific notation, when you see a number in scientific notation, it means to move your decimal point either left or right by a certain amount of decimal places. So I'll show you how you would do this one. And some calculators will handle a problem that's written in scientific notation, but on the praxis test, they don't give you a calculator that powerful. So you definitely need to know how to switch this over to just a regular number, not scientific notation. So when the exponent is negative, that means move your decimal point 2 places to the left. So if I move it 2 places to the left, that would be 0.059 is what this number is. 2 places to the left, this takes it to the 5, and then one more place to the left puts that 0 right there. So that would be that number. And then this number, when it's to the second power, it means, or a positive power, it means move the decimal point to the right. So this one we move to the right 2 places. So that'd be 57 plus another 0, 570. And then at that point, you can just use a regular calculator and multiply them together. So it's not too bad to do that. And then they give you another one down here of multiplying, and it's the same type of thing. This one, you'd move your decimal point 3 places to the left, and this one you would move it 8 places to the right. And then, well, here, we'll do this one. What the heck? Let's do it. So the first problem is 3.5 times 10 to the negative third. And that's times this whole thing, 1.7 times 10 to the 8th. You could also see these as a division problem too, one scientific notation over another. But anyway, with this, you can move the decimal point 3 places to the left. It would make it 0.0035 is what that number is. And then this number, 1.7 times 10 to the 8th, means move your decimal point 8 places to the right. So that'd be a 1, 7. And moving it to the right of 7 takes care of one of these 8 places. So then we'd have to go 7 more places. 1, 2, 3, 4, 5, 6, 7. So these are the 2 numbers you need to multiply together. And then look, they want the number written in scientific notation. So to do that, we'll bring this over here and just use a calculator to finish it off then. So the first number is 0.0035, and that's times the second number, 1, 7, and I think 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. I think that should do it. And so I get this number, 595,000. Now they want the number written in scientific notation. So to be written in scientific notation, you can only have one number to the left of the decimal point. So right now the decimal point's here. So I have to move this decimal point 1, 2, 3, 4, 5 places to the left. So this number would be 5.95 times 10 to the, let's see, 1, 2, 3, 4, 5. So it'd be 10 to the 5th. And I just remember that this is a positive number because when you think about it, a positive exponent makes the number bigger because you're moving the decimal point to the right. So if you move the decimal point to the left, you're taking a big number, making it smaller. So this has to be a positive number here. So for example, if I had to switch this back, the positive 5 means move your decimal point 5 places to the right, which makes it a big number like we did with these. So anyway, that would be the answer to that problem. It'd be 5.95 would be right here. And it's times 10 to the 5th. So just a 5 goes right there and that should do it. Yep. So we did these, like I said, in the other video. I don't know if I want to do every single one of these again. I don't know if you have any ones you really want to see or anything. This I did problem just like this, both of these on the last video. And this one goes over rules for exponents. This one you set up 2 equations based on the 2 rental car policies, rental car A or B. This is the starting of factoring right there. And with factoring, I'll do one of those after this one. So factoring comes up a lot in algebra. And what that is breaking things down. So here I'll do this one, 2w to the 6th, x to the 4th, plus 8w to the 9th, x to the 10th. And what you're doing is looking for something that's common to both of these. And for example, the 2 will go into 2 and 2 will go into 8, and there's no bigger number that goes into those 2 numbers. So 2 is a common factor. There's 6 w's here and there's 9 w's here. Well, what's common to both of them? Each of them have at least 6 w's in it. So I'll write w to the 6th. This one has 4 x's, this one has 10. So they both have at least 4 x's. And that's what you're factoring out. When you're factoring out, you're dividing out. So if you take this whole thing divided by the whole thing we're factoring out, which is identical to it, anything divided by itself is 1. Then take over here and see what extra you have and how many times extra it's in there. Like for example, 8 is 4 times bigger than 2. 8 divided by 2 is 4. How many extras w's do you have? Well, here you have 9, here you have 6. So you have 3 extra w's here. And how many extra x's? Here you got 10, here you got 4. Subtract, and there are actually 6 extra x's. So that is actually the answer to this thing right here. And you actually type it in with the letters and all that sort of thing. So I'll go ahead and do one like problem 8, do a couple more of these ones that I already did last week, and then we'll move on here. So on 8, you're breaking down a square root. And I like to show an easier one first. Like for example, if we had the square root of, let's say 50, what you do, and this one's the exact square root. And what that means, see, if you would do the square root of 50 on a calculator, you're just going to get a decimal approximation for it. But what you can do here is break 50 into its primes. Like for example, 50 is 2 times 25, and 25 is the same as 5 times 5. And what you do is you take out 1 for every pair. Because really this 5 times 5 is 25, and the square root of 25 is 5. And left inside that square root is a 2. And that's actually how you get the exact answer for square roots. You don't use a calculator, you use this method that I'm showing you right here. So let's try the problem that's listed there, which is the square root of 294. So what you have to do, the hardest thing is, and this is why it's probably on the praxis, is because you have to break things down to the primes. And breaking numbers down to the primes is one of the fundamental things to know in terms of how to add fractions, because you have to get a common denominator, and breaking things down is a good way to go. So what I do is off the side here, just write down this number here. I'll do it here, 294. And since it's even, I know 2 goes into it. So I take 2 into 294, and it goes 147 times. At this point, 147 isn't even, but if I add up the digits, 7 and 4 plus 1 is 12. And since 3 goes into 12, 3 will go into 147. So 3 goes into 147, 3 goes in 14 4 times, the remainder 2, and 3 goes into 27 9 times. And then 49 is just 7 times 7. So what I did at this point is, just like I broke down the square root of 50 into 2 times 5 times 5, I broke down square root of 294 into the square root of 2 times 3 times 7 times 7. And what you do is you take out 1 for every pair. See, this is 49 right here. 7 times 7 is 49. And the square root of 49 is known. It's a whole number. Square root of 49 is 7. And the only thing left underneath the square root is 2 times 3, which is 6. So that would actually be the answer to that problem. And they don't expect you to type that in. They just want you to get the pieces here. So this A, the number in front, would be 7. And the number inside the square root, that B right there, would be 6. And that's all there is to that problem. But anyway, that's breaking down square roots. On this one, I did this one last week also. This is just, you simplify this by multiplying the top and bottom by the square root of 6. It's called rationalizing the denominator. So you multiply the top by the square root of 6 and the bottom by the square root of 6, and it cleans it all up. And I guess we can save that for you guys to see. And let's see here. Is this anything here? Okay, well, with these, let's go ahead and do 10, and then I'll do another factoring one, because even problem number 10 gets involved in factoring. So I'll go up here and do problem number 10. I don't know how I got clear down there. So this one says solve this: x squared plus 6x minus 5 equals 0. And what you want to do is you want to factor this into 2 binomials, and it goes like this. So you say the x squared breaks into x and x. And then what we do is we're looking for factors of -5. Let's check this out here a second. Yeah, factors of -5 that add up to 6. Wow, I don't think this one has a solution to it. Let me just check this a second. Yeah, this one does not have a whole number solution. So for this one, you'd have to use what's called the quadratic formula. So this would be a pretty tough one here. Let me just see if the video shows so you guys would know how to do it. Yeah, they go through the quadratic formula. And so I'll show you how that works then. So this one does not factor. You'd have to, here's the quadratic formula: x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And what you have to do is you get your a, b, and c on this equation by pulling off the coefficients in that equation. So the a is the number in front of the x squared. So we have 1x squared. The b is the number in front of the x, so that's 6. And the c is the number here without an x, and that would be -5. And then you substitute those in there. You get the -b, that'd be -6, plus or minus the square root of, I'll put it this way, 6 squared. I'm putting the 6 in there for the b, and that gets squared, minus 4 times the a is 1 times the c is -5. And all that is over 2 times a, and the a was 1. So it's just plugging things into this formula. And at this point, we get x equals -6 plus or minus the square root of right here, 6 squared is 36. And negative 4 times 1 times negative 5 is 20. See, the two negatives make it a positive right there. And all that's over 2. And we clean it up one more time. That's negative 6 plus or minus the square root of 56. 20 plus 36 is 56 over 2. Now at this point, you're going to have to use a calculator at this point. But we got it broke down that any calculator with a square root can do it. So what I would do is I would probably use let's do it this way. I'm going to say parentheses, negative 6 plus the square root of 56. And all that gets divided by 2. If I do that, I get this answer of 0.7416. But you have to do the same problem again with a minus sign in between the negative 6 and the square root of 56. See, I just did it with a plus sign. And you have to do it again with the minus because you're going to get 2 solutions. So what I'm going to do is hit all clear, arrow up, and I can go over here and edit this problem. So what I'm going to do is delete that plus sign and put in a minus sign. And I get this answer. So my other answer is negative 6.7416. And you'll see that those are my 2 answers right there that I have on that. Yeah. So I wanted to show you another one with factoring. So I'll do problem 12 for practice. Or let's see if we can find one a little bit tougher so you can see a good example of it here. This one is just really factoring this thing here. I'll do this one. This is number 13. We can take a look at that. So in 13, we need to factor this thing, 4y squared minus 12y plus 9. You always look for a common factor first. See, there's 3 terms. None of them, all 3 terms do not have a y. This one does and this one does, but that one doesn't. So there's no common factor of y. There's also no common factor of numbers that you can factor out. Like 2 will go into 4 and 12, but 2 won't go into 9. So there's nothing you can factor out. So what you do then is like we did, like I was trying to do earlier, you break it up into 2 sets of parentheses. You divide this thing up. Like for example, 2 numbers that multiply to give you 4 are 2 and 2. And 2 things multiply together to give you y squared are y and y. So in other words, this thing right here, this 2y squared right there, that comes from these 2 things being multiplied together. And then we need factors of 9 that when I substitute them in here, I get negative 12. So a lot of people think that the only factors of 9 are 3 times 3, which gives you 9. But that's not true. There's also 9 times 1. But besides that, you can also get a positive 9 if you multiply 2 negatives together. Like for example, negative 3 times negative 3 is 9. And negative 9 times negative 1 is 9. So it could be any of these. And what you do is you can try them, but you're trying to get, when you do this little foiling thing, and maybe you've heard that word before, foiling, is you're trying to get this middle number. So I can't add up to negative 12 if both of these are positives. So I'm going to try negative 3 and negative 3. And I'll show you that that works because negative 3 times negative 3 is 9. And then you check your what's called your inner and your outer. So if I check my inner and my outer, negative 3 times 2y is negative 6y. And negative 3 times 2y here is also negative 6y. And when I add these together, I get negative 12y. So in other words, that's what it factors into right here. So in other words, we broke this thing apart into this right here. And you can actually write this, since it's the same thing twice, we could write it as 2y minus 3 quantity squared. And that's what the answer is there. So, and then you can check it, you know, if you want to check every piece of this, you could, it's called foiling this stuff together. Here, I'll show you that 1 second. 2y minus 3 times it another 2y minus 3. This is a check of this problem. I'll just put it this way. We're checking to see if it's right. So what we have to do is take the 2y through these parentheses. So I'll put it over here. We got to take the 2y and multiply it through that 2y minus 3. Then we got to take the minus 3 and multiply it through this set of parentheses, 2y minus 3. And we're just checking to see if we get back to our original problem up here, right here in this area. So taking the 2y through, 2y times 2y is 4y squared. 2y times minus 3 is minus 6y. Minus 3 times 2y is another minus 6y. And minus 3 times minus 3 is positive 9. And you have like terms in the middle. Here's your minus 6y and a minus 6y, which gives you minus 12y. And over here is your plus 9. And that's a check because we got right back to the problem that we started off with up here, right there. Yeah. All right. So you end up answering a lot of questions like this one on 14 when you're factoring these things. Like on 14, this is something that you could even ask kids as soon as they know their multiplication tables. So on 14, it says find two integers whose sum. So you're looking for two numbers that sum, or in other words, add up to. That's what sum means. Add up to 6, and their product. Product means they're multiplied together, and they multiply together to 8. So if you can do this stuff, which kids can do, then you can actually do algebra and factor things. So think of this, first of all, two numbers that multiply to give you 8. Well, I think right away people think 4 times 2. And you know what? Not only is 4 times 2 8, but 4 plus 2 is 6. And that's a good thing to do with students in elementary school, is give them problems like that. Like, for example, can you think of two numbers that add up to, they add to, let's say 11, and they multiply to 24. So how you doing, Kelvin? You okay? So I don't know if, Jessica, are you there? Okay, well, I'll go ahead and do this one. Two numbers that add up to 11 that multiply to give you 24. I always think of what multiplies together, first of all. And you could think of like 6 times 4 is 24, but 6 plus 4 is 10, not 11. But 3 times 8 is 24, and 3 plus 8 is 11. And that works, and you do those type of things. And so with these problems like 15 and 16, you have to factor these down. Actually, with this one, there's only one thing that you factor on 15. So with 15, doing this in pieces here, you got an x plus 2. On the bottom, we have this x squared. So I'm not going to write the whole problem down again. We're just going to do this. We're going to go ahead and factor this x squared minus 2x minus 8 right over here. So the x squared breaks into x and x. And now you're looking for two numbers that multiply together to give you -8 that add up to -2. So that would be -4 and +2. Because 2 times -4 is -8, this number right here, and 2 minus 4 is -2, that right there. Now also remember, when you're dividing by a fraction, you change the problem to multiplication and you invert the second fraction. So the x minus 4 goes on the top and the x minus 1 goes on the bottom. Then at this point, you can cross off anything on the top with anything on the bottom. That's the same. So x minus 4, x minus 4, x plus 2, x plus 2, and all you're left with is 1 over x minus 1. And that would be the answer to that problem. And this was the problem that I think we stopped on last week, right here. This is a messy one, but See, with this one, there's an X that factors out and so on. So tell you what, let's do problem 17, and then we'll move on to the graphing here. So one more of these factoring type of problems. So on 17, I'll go ahead and write the problem down. And I tell you what, to save time, I will go ahead and invert the second fraction since I see that it's division. So we got x squared minus 3x minus 40. And then we have to flip this second fraction via x squared minus 64 on the top and a 5x on the bottom, 5x squared on the bottom. Now with this one, the top one here, taking it one piece at a time, the top one has a common factor of 3 because 3 will go into 3 and 3 will go into 15, plus both of those terms have an x. So that's what you need to factor out. When I factor that out, 3 goes into 3 one time, but I can see that I have one extra x here. Here's an x squared and here's an x to the first. So there's an extra x in the first term. Then over here, 15 divided by 3 is 5. And there's no extra x's. There's an x here and there's an x here, no extra x's. On the bottom of this one, there's no common factor. So we do our parentheses stuff. The x squared breaks into x and x. And now you're looking for factors of 40 that add up, factors of negative 40, I should say. So the only way I can get a negative is if one of the two factors are negative, and they add up to negative 3. Well, for example, negative 8 times positive 5 is negative 40, and negative 8 plus 5 is negative 3. So that's how that one factors. And it would take a while to think of that. Over here, the x squared minus 64 breaks just like the other ones do. So this would be x and x. And here, you're saying two numbers that multiply to give you negative 64, but they add up to 0. The reason is because this thing right here, this x squared minus 64, you can think of it as x squared plus 0x minus 64. So in other words, we're looking for factors of negative 64 that add up to 0. And that would be negative 8 plus 8. Negative 8 plus 8 is 0. See, most of these have a middle term here. But if they don't, that means the middle term that you're looking to add up to is 0. And then we get the negative 64 by doing negative 8 times 8. So that would be it right there. And on the bottom, that doesn't break down. It's just a monomial. So that's just 5x squared. Then at this point, crossing out like terms, the x minus 8, the x minus 8, the x plus 5 with the x plus 5. And we can cross off one of these x's with one of these. So that knocks us down to the first power. So at this point, the only thing that we're going to have left on the top is a 3 and an x plus 8. So a 3 and an x plus 8. And on the bottom, the only thing we have is a 5x. So that's going to be the answer to this first one right here. And then they want to get what restrictions. And the restrictions they're talking about is anything that makes the denominator equal to 0. So looking at the denominator, this was a denominator right here. And the factors we got from that was x minus 8 and x plus 5. And the thing that makes x minus 8 equal to 0 is 8. The thing that makes x plus 5 equal to 0 is negative 5. The numbers that make x squared minus 64 equal to 0 were positive 8 right here and negative 8 right there. And this was also in the denominator. And the only thing that makes this equal to 0 is 0. Now you don't have to list the same number twice. I have 8 down here twice. So really your listing would just be these 4 numbers right there. And you can see that's what they have. So that's the problems we got through. And then most of these problems for today are duplicate problems of what we did earlier in algebra with the graphing and that sort of thing. So with 18, we've done plenty of these. This is where you get 2 points from the graph. So looking at this, I can see that it goes through the point 0, negative 4. Right here's a point on the graph. And I can also see that it hits right at, let's see if we can find another spot that it hits right on the money. And Well, it looks like here's a place clear out here at 10, 2. 10, 2 looks like another place. So you want to be right on the crosshairs. So see, I can't use like this spot. It's not right where the horizontal and vertical line hit. You can't use this. That looks like a little bit above, a little bit below, above. That one probably would have been able to be used too. This one right here at, that would be 50, -1. I could have used that. And actually this one way out here, that's not 10, that's actually 100. See, 20, 40, 60, 80, 100. So we can use that 100 too. So let me use that point. So it's 100, 2. So to do this, you first get the slope. M stands for slope. So you subtract the y values, 2 minus a -4 over, subtract the x values in the same order, 100 minus 0. And you can see how much it rose and ran and that sort of thing. So 2 minus a -4 is actually 2 plus 4, which is 6. And 100 minus 0 is 100. And so you can reduce this down a little bit. 2 goes into 6 3 times and 2 goes into 150 times. So that's my slope there, 3/50. So that's why it hit on this point right here, because it rises from any point, like at this -4 right here. It rises 3 to get you to -1 and runs 50. So this point right here at 50, -1 is actually on the graph. So at this point, we know the slope, and also we know the y-intercept. The B is where it hits the y-axis, and this one hit right on the money there at 0, -4. See? So that means the B is -4. So the equation is y equals 3/50 x minus 4. And that would be the equation. If you put in one of these points in here for x, you'll get that out. Like if I put 100 in for x, 100 divided by 50 is 2, 2 times 3 is 6, and 6 minus 4 is 2. It works. Or if you check this one, put 0 in for x. If I put 0 in for x, 3/50 times 0 is 0, and 0 minus 4 is -4. Even that point right here that I didn't use, 50, -1 right here. You can check that, 50, -1, and see if it is on this line. If I put 50 in for x, 50 over 50 is 1, 1 times 3 is 3, and 3 minus 4 is -1. That's it. So that's the equation that you would type in, and you can see it right there. Okay. So this is the same thing, get the equation of the line. Exactly the same thing, get the, see here's a point at 0, 2, that's going to be your B, and I can see that the slope is drop 1, 2, 3, run 2. So right there's your slope of drop 3, which is -3, run 2, and then that's your slope, which has the x with it. And then I can see that the y-intercept is 2. And that would be that equation. It's that quick, really. And that would be a problem. Not only do you get right on the praxis test, but you would also get it right very, very quick. Here's another one. Can we get just the slope? That's all they want. Well, looking at this, between 2 points, like here's one that hits right on the money here, and here's one right here. So looking at those 2 points, so here on problem 20, the 2 points I'm looking at, here, I'll go ahead and write this one down. So in problem 20, the ones that to me look like they hit right on the money is this one right here at -3, -1, this point right here, -3, -3, -1, and another point is right down here at 0, -5. And all they want is a slope. So yeah, you could use a slope formula, or we could just count. From here, we drop 4 down, right? 1, 2, 3, 4, and we run 3. 1, 2, 3. So it looks like it's -4/3. And there you go. Or you could do it with the formula, subtract your y values, -5 minus a -1, and on the bottom, subtract your x values in the same order. 0 minus a -3. And if you work this out, on the top, -5 plus 1 is -4, and 0 minus a -3, two negatives make that positive. So it's -4/3, exactly what I got right there. So this is the same thing once the slope once it slope intercept form. So let's go ahead and do this one. This one is number 21. So on 21, again, you're looking for points that hit right on the money. I can see that it hits through the point 0, -4, the y-intercept. And the next point I see where it hits right on the money after 0, -4 is right here at this one. And that would be the point 1, 0. So I got my 2 points. Now they want the equation in slope intercept form. I know since I have this right here as my y-intercept, it's the y-axis there. So that means on the equation y equals mx plus b, my b is the y-intercept. So I know this b right here is -4, this spot right here. And I could just do my counting here to get how steeply it's going up. So from -4 to get up to this point, it has to go up 4, see, from -4 up to 0, up 4, right 1. So the slope would be up 4, run 1. So that would be the equation. I can clean it up a little bit because 4 over 1 is 4. So that's the same as y equals 4x minus 4. So that's the equation in slope intercept form. I'll show you that that's right. And then they want it in standard form too. All standard form is getting the x's and y's over on one side, no fractions. We don't have any fractions, so let's get your x's and y's on the same side. So this right here is called slope intercept form. And getting it into what's called standard form, you get your x's and y's on one side. So right now we have it in slope intercept form, y equals 4x minus 4. I'm going to subtract 4x from both sides. And what I get is -4x plus y equals, see, this is out of there, -4. Now you also don't want your leading coefficient to be negative, and you can clean that up by just multiplying the entire equation by a -1. And that will just take care of that negative, make it a positive 4x. That would be a minus y, and over here is a positive 4. And that's as clean as it can go right there with standard form. And you can see that's the answer. Okay, with this one, again, you're just getting the equation that goes through these points. The only thing you do at the end is once you get that equation from the 2 points, like I can see that the y-intercept is, looks like it's -6. So the b is going to be -6. And I can see that from -6, it also hits here at 2. So that's rise 6, run 2. So that would be rise 6, run 2 with an x on it, okay? So this equation simplified a little bit would be y equals 6 over 2 is 3, so that's 3x minus 6. Now, that would just be the graph of a solid line. Since it's graphed below the line, that means that we want this inequality less than to be in there. The dotted line means we don't include the line. If it was included, we'd have an equals to with it. But it's just y is less than 3x minus 6. And that would be the answer to that problem right there. See, this would be a less than, and this would be a 3x minus 6. Yep. Okay. The solution to a system of equations is where they intersect. So this intersects at the point -3, -1. And that's all there is to that problem. Very, very easy. And there is a problem on the praxis like that. This is a tough problem. They want you to graph these two things kind of quickly without a calculator. So let's do the easy one. The easy one is this one right here, the line. So we just click on the line and we see that the y-intercept is -5. That's right here. And we see the slope is 2, meaning rise 2, run 1. So there's that one. This one, this quadratic right here, it's called a quadratic because it's to the second power. This goes back to translations that we had back on geometry. So if you remember, a quadratic looks like this, either opening up or down. It's called a parabola. And this one's going to be shifted. It's the opposite of this number. So it's 3 to the right. And then it go with this number up 1. So it's going to hit right here. And then just go to the right one or left one, either one, and move it up 1. And there you go. That would be the graph of those two things. Again, the first one is just a line to the first power. So it's just a line. We did the y-intercept and then the slope, rise 2, run 1 to get a second point. There's your line. With this one, since it's to the second power, I know it's going to be this U-shaped thing. And I know that I can get this vertex point by doing the opposite of this on the x-axis. The opposite of -3 is +3. So move it to the +3 and move it up 1. Boom, that gives you your vertex point. Then from that, since this is positive, you're going to go up 1. So you can go right 1 and up 1. You can go left 1 and up 1. But either way, that's all you do. If it was negative, you'd go down 1 over 1, and it'll give you an upside down one. And then the solution is just like that previous problem. It's where they intersect. So where do these two things intersect? Well, you can see one point that they intersect is right here at that vertex point, which is the point 3, 1. So 3, 1. And I think we got to say, put a comma in between these 2 points. And the other point that they intersect is right up here. And you can see that's at the point 5, 5. See, 5, 5. That's where they intersect. So let me put that one down. 5, 5. And that should do it with that one. Okay. And this one is just graphing this. So again, you see it squared. So it's going to be a parabola. And this means shifted to the right one, and this is down 1. And it's positive, so it opens upward. So I'll show you how we do this here. The graph's really big, but we just choose this. And let me go up here so you can see the problem. So again, we just go to the right one. Opposite of -1 is +1. Go to +1 and then go down 1. Go with the sign on this. +1, then down 1 right here. And then since that is a positive, we go up. So we don't go straight up. We go right 1, up 1 like that. Or you can go left 1, up 1. It doesn't matter, but it gets you this both sides going to the same place. And that's all there is to that one. Oh, I guess we wanted to know the vertex point. The vertex point is right here at 1, -1. So we'll put that in. Okay. Then down here, it's a quadratic again. See, the x is squared. The vertex point is going to be to the right 1, up 3. Opposite of this one, opposite of -1 is +1. That's why it's to the right 1, and you go with the sign on this. So right 1, let me choose this. I think we're ready to go. So right 1, up 3, right 1, up 3 right here. Now it's positive, so it opens upward. But you see, this has a 2 in front of it. So that 2 is going to cause it to go like a slope type of thing. Right 1, up 2, right there. And that should do it. And the vertex point, we'll put it in this time, is at 1, 3. That's the location that we found that is the turnaround point on the parabola. So let's go ahead and submit that. And another one of these. So this one's going to be to the left 2, down 3, right here. It is positive, so it opens upward, and it's just right 1, up 1, right there. That's it. See, this vertex point's at -2, 3. It's positive. See, this is positive over here, so that's why it's opening up. And there's no number in front, so you just think of this as being 1x. So that 1 is the same as 1 over 1. Rise 1, run 1. Boom, you got it. So let's see what we're supposed to do with this one. For an equation for the graph shown below. Oh, find an equation for the graph below. Okay, so this is just going the opposite, using the graph to get what the equation is. So with this one, first of all, I notice that it's going downhill, so it's going to have a negative. See, it's a parabola that opens downward. Then it's going to be x minus 1 because it's been shifted to the right one. See, it's over here at 1. So now I have to put minus 1. And then it's been dropped down 2 points. So we also have to say it's squared here. And then drop 2, minus 2 right here. So a lot of things going on. It's upside down. First of all, it's a parabola, so it has to be squared. It's opening downward, so that's why that negative is there. Then I look at the vertex point and I see the x part's at 1, and I need the opposite of that to go inside of here. That's why we've been saying take the opposite of this number here. See, if we were going to graph this, we would say, what we take the opposite of this number. The opposite of -1 is 1. So that's why we go to the right one. And then we go with this number here to say how much it's raised, translated up or down. So this is shifted down 2 right there. And that's it right there. Now you can also make sure, and let's do this real quick. Is the next point after this over 1 down 1? No, it isn't. This is actually over 1 down 2. So really, this number in front of here isn't a -1, it's a -2. See, if you can see this, this isn't over 1 down 1. It doesn't hit right here. It hits right here. So it's over 1 down 2. That's why I need that to be a 2 there. That's just like not this problem, but it's like this problem. See how the next point that it hits at after the vertex point isn't 1 to the right and 1 up. It's over 1 up 2 because of that 2 right there. And that's what's going on with this problem right down here. So that should be the equation right there. And that's a pretty tough one. And we're getting really close to the end here. I think we have 2 problems left. So on this one, you can get the idea with this one. I find it to be pretty tough, but here's your x values. And this is read f of x. And in other words, it's like your y values. You get these by substituting the 0 into, or these values 0 through 9 into some function that we don't see. So, but we can get what the value of the function is by just looking at the table. For example, f of 5 means, see, this means when x is 5, what is y? So when x is 5, the y value is 6. The f of x value is 6. So this answer is going to be 6. This says if f of x equals 7, then what does x equal? So go to your f of x column, that's this one. Find out when it's 7, it's right here. Now what x value gives you that? 2. So this answer is 2. Again, it says f of x equals 7, so look on your f of x column. F of x column. Look for 7, it's right here. Then what x value does that? 2. Done. Now f inverse goes the opposite way. It's here, let's go to this one. F of 5 up here means that the value that's inside the parentheses is your x value. When it says inverse, it means you're going the opposite way. You're putting the 6 in from over here. So looking for 6 over here, we see that when we go back towards the left, we get 5. So this answer here is going to be 5. So now this is an inverse. So we're going from the right to the left, and it's saying what value over here will give you 2 over here. Well, I see the 2 right here, and the value over here that gives you that is 7. So this is going to be 7. Now this one is double here. So it's f inverse of 6. So that means we're thinking of it this way. We're putting, since it's the inverse, we're starting on the right, and we got a 6 here. And f inverse of 6 gives you 5. So this one, let me write it up here. So this is, I think, problem number 29, and it's the last part of 29. So this is f inverse of F inverse of 6. So you got to work it from the inside out. So doing this much right here, when you're doing the inverse, that thing -1 right there, which is called the inverse, then you have to work from right to left. The regular function f of 6 would be left to right. When you see inverse, it's right to left. So f inverse of 6 means we're looking for the 6 right here. And when I look for 6 right here, I see here it is. And what does that give me? 5. So I know f inverse of 6 is 5. Now I got to get f inverse of 5. So still it's an inverse. So look for 5 on the right-hand side. Here it is. And what do I get on the other side? 7. So it looks like it's 7. And let's see if it is. Boom. That's it. Yep. And well, we can do another one if you want to, but we'll finish it up here on this. So 30 is just a true or false type of thing. It says click all which are true. So the first one here says B over A plus A over B is equal to B squared plus A squared over A times B. Well, I think that is true because to add fractions, you have to get a common denominator. Like for example, if the A was 2 and the B was 3, you'd get the common denominator of 2 times 3 or 6. And that's how you get a common denominator. So that's AB. And then what you say to yourself is, what's extra in this denominator that's not in this? Well, a B. And B times B is B squared. And over here, what's extra in the common denominator that's not in here? An A. And A times A is A squared. So these things are true. So the first one is true. Let's check the second one. So with the second one, we have, here, I'll just do a line here. So the second one is A plus B over C. Does that equal A over C plus B over C? Well, when you have a common denominator, which this is, you can put the two things together. Like for example, if you had like this, 1/7 plus 3/7, don't you get 1 plus 3 over 7, right? And that's what we did here. If you have a common denominator, you can add your numerators together and put them over the common denominator. So that's a true statement. Yep. Let's go to the third one. On the third one, it says A over A plus B is equal to 1 over B. Well, the thought there is they're saying, well, I can cross off these A's and just get 1 over B. But that's not true. You can't do that. That's false. And I can show you with real numbers that you can't do that. If that was true, if A over A plus B equals 1 over B, then 5 over 5 plus 3, by the same idea, the 5s would cross off and you get 1 over 3. But it's not. 5 over 5 plus 3 is 5/8, and 5/8 does not equal 1/3. Sorry, 5/8 does not equal 1/3. So no, that's not true. So this is a no. It's false. Let's check the fourth one. The fourth one says, is it true that A times B is always greater than A? Now it says that these are positive integers. Now positive means that we're talking about numbers like this, 1, 2, 3, 4, and they're integers, they're whole numbers. They got to be positive though, so we can't be using 0 or negative. So is it true that if you take any positive number, 1 or bigger, times another positive number, you always end up with a number that's bigger than either one of these original numbers? No, it's not true. It didn't say that we couldn't use 1. So 1 is a positive integer. So if we take 1 times 3, is that greater than, okay, here, right here, I think we got it. This is still true. 1 times 3 is greater than 1. Let's flip it around here. Let's let the B be 1. So checking the A times B is greater than A again. How about 3 times 1? Is that greater than 3? It isn't. 3 times 1 is 3, and 3 is not greater than 3. So I'll say no, this is not true. So this one is also not true. If it would have said, is this greater than equal to A, we would have been okay. Or if they didn't allow the number 1 in there, we would be okay. And then the last one is A over B plus C. Does that equal A over B plus A over C? No, it doesn't. Because to add these fractions, you'd have to get a common denominator. And the common denominator would not be B plus C. Like, for example, if you have 1/2 plus 1/3, your common denominator is not 5. It's not 2 plus 3. Your common denominator is 2 times 3. Your common denominator is 6. And the same way here, your common denominator between B and C would be B times C, not B plus C. So this is not true either. So it looks like the only ones that we have that are true is the first two. So we got that right there. So that's really it. And the only thing we have left for the semester is to just go over any practice test questions that you might have. And I'll just see what questions you have on our next class on Wednesday. So I'll stop the share right there and also stop the recording.